Students, in this session, let us solve one problem on location of the resultant force in two-dimensional system. Let us read the problem. Four forces act on a 700 mm into 375 mm plate as shown in the figure. 700, so here in the diagram 500 plus 200, so totally 700. Height is 375 mm, so it's a rectangular plate. In the rectangular plate, four forces are acting. 1, 2, 3, 4 forces are acting. So we have to find the resultant. Resultant means the single force that replaces the four forces. We have to find the resultant, and also we have to locate the resultant. Locate the resultant of the 2 points where the line of action of the resultant force intersect the edges of the plate. So here the edges of the resultant force meet the edges. So this is the resultant force. Finally we are getting. So it intersect this edge AB and also intersect the edge CD. So the distance A on the edge AB and B on the edge CD. So we have to find. So this is the question. So let us solve this problem. So here, in order to solve this problem, we have to use the resolution principle of resolution of forces. Resolution means we have to convert the inclined forces into vertical and horizontal forces. So here 340 Newton force is there. So this is an inclined force. We have to convert into one horizontal and vertical. It's component. It's a horizontal component and vertical component. So similarly, this 500 Newton force, this is an inclined force. We have to convert it into horizontal and vertical forces. But the 600 Newton force is already a vertical force. No need to change anything. So here also on 760 Newton, this is also horizontal force. So no need to change anything on this. So in order to convert these components, horizontal and vertical component of this inclined force, we have to find the inclination with the horizontal. We have to know, but it is not given directly. So how to find means this angle theta 1. So see this triangle, this angle theta 1. This theta 1 is the inclination of this force. Because this is a horizontal force, horizontal line. This is also horizontal line. This is a line. So this line, the angle with this makes the horizontal theta 1 is this angle. So similarly theta 2 is the inclination of this force, 500 Newton force. So we have to find theta 1 and theta 2. How to find? So here using this triangle, right angled triangle, one angle is 90 degree. So it is right angled triangle BED. So in the triangle BED, so we have to find theta 1. So we can use tan theta because opposite side and adjacent side known. So we can use tan theta. So we have to find theta. So we can use the tan inverse of the opposite side by adjacent side of this triangle. So we will get the angle as 61.92. Similarly, for finding the value of theta 2, so we can use this triangle ACE, right? So AEC, this triangle. Here also the tan theta is equal to opposite height of the this length 375 and the adjacent side is 500. So we will get the angle as 36.86. So using these angles, we can get the value of horizontal component and vertical component. Horizontal component is the force into cos of the angle, cos theta. So this vertical is sin theta, force into sin of the angle. So here also one horizontal and one vertical force. So we converted all the inclined forces into vertical and horizontal force. Now we can find the resultant force, right? So resultant force, we know the formula for resultant force as sigma h square plus sigma v square. So we have to find the sigma h first, right? Sigma h. So how to find the value of sigma h means we have to add all the horizontal component, isn't it? So we have to add all the horizontal components. So here horizontal forces 1, 2, 3. So 3 horizontal forces are there. Among this force and this force towards right, so positive. This is towards left, so it is negative. So this positive value 340 cos 61.92 plus this value 760 and minus this force is acting towards the left, so it is minus. So minus of 500 cos 36.8. So we get sigma h as positive value plus 520 Newton. So sigma v means we have to add all the vertical components. We have to add all the vertical components. Here also this is vertical force, this is also vertical force. So 3 vertical forces are there. So all the forces are acting upwards, right? Upward force and upward force. So all are positive. So we can add all the values. We get the sigma v value as 1200 Newton. This is also positive. So okay. So by using this value of sigma h and sigma v, we can find the value of r by substituting in the formula. We get the value of r as 1307.82 Newton. So then alpha value, inclination of the resultant with the horizontal, alpha value can get from the formula tan inverse of sigma v by sigma h. That is, we got the value of angle as 66.57 degree. So location of the resultant. Here, see this, sigma h is positive, so right side towards right side. Sigma v is positive towards up. Okay, so the resultant will be in between this. So it is in first quadrant. Angle will be like that. Now we have to locate the resultant, right? We have to locate the resultant. So we found the value of the resultant force. Now how to locate it? For location, so I am assuming that it is crossing like this direction, same direction, so 66 degree. So approximately I draw one line, right? This line. So I am assuming A as this distance, unknown value, distance from this point A. Okay, unknown value. And when it is meeting at the point B, meeting at the point at this CD edge, so it is, I am assuming that it is meeting at a distance of B from the point C. So we have to find A and B. So for that we can use the moment principle. Okay, moment principle. So for that, just I am going to find the sum of moments about the point C. So at any point we can take, no problem, but we can take the moment about that A or B or D, whatever it may be. Now I am taking for easy calculation, I am taking moment about C. Okay. Taking moment about C means what? We have to hinge, okay, hinge at the point C. This symbol, sigma moment about C means sum of all moments about C. So here, see this diagram. Here how many forces are there? 1, 2, 3, 4, 5, 6 forces are there. So moment will be created only by the force. So by the application of 6 forces, the body will rotate about the point C. So here at the point C is hinged. So for that, for understanding, you can have a rectangular plate in your hand, right? Rectangular plate in your hand, and you arbitrarily fix A, B, C, D and E. Okay, and you hold that plate at the point C, because we are going to find the sum of moments about C. So it is going to hinge at the point C. So you hold the plate at the point C and you try to apply the force and see whether it is rotating and which direction it is rotating. So you are holding at the point C. Now consider this force, 340, this force. Okay, so we have to consider 6 forces. 6 forces will we have to consider. So this force. So here hinging, you are keeping the plate, you are holding only at the C, and with your right hand you are applying one horizontal force in this direction. So you will try. Now it will try to, this plate will rotate. Okay, you are pulling like this. So the try to come this direction, but it is hinged at the point C. So it will rotate about this center. It will rotate. In which direction it is rotating? It is rotating in clockwise direction. So positive. So the symbol is positive. So the force value is 340 cos 61 into perpendicular distance. So here this force line of action is horizontal, right? So perpendicular to this line of action means this distance. So you have to understand very clearly that we have to find the perpendicular distance of the force, okay, up to the point C, up to the hinge point. So this application, this force is acting horizontal. So this vertical distance 375 is our distance up to the point C. Okay, so we consider. When you consider this force, this upward force, okay, 340 sine 61.9. Now also you have a plate hinge at keeping the plate with your left hand at the C, and you are applying one upward force with the right hand. Now it is fixed at the C, so it's try to rotate in this direction. When I am applying upward force at this point B, it will rotate in this direction. Which direction? It is in anti-clockwise direction, so it is minus. Okay, the force value is 340 sine 61. Then perpendicular distance. So here this line of application is vertical force, right? So perpendicular distance means this direction, this length. So we have to find the length in this direction. So we have to measure perpendicular to the line of application, so up to the point C. So what distance? This distance up to the point. From the force we measure perpendicular distance up to the point C. This distance is 500 plus 200, so totally 700. So I am converting millimeter into meter. So you have to divide by 1000. 700 means 0.7 meter. So then, two forces over. Then consider this 500 sine theta, this vertical component. This vertical component will not create moment at all. So you try to experience with your live example. So now you are holding at the point C and you are applying horizontal force, the vertical force. So this line of application meet at the point of hinge. So no distance, no perpendicular distance. So the moment is 0. So no, don't want to consider. Then consider this force, 500 cos 36.8 towards left side. It is pulling towards left. So it is hinge at the point C. It will try to rotate in this direction, anti-clockwise direction. So it is minus, force value is this value. Then perpendicular distance, this is horizontal, so perpendicular means this distance, okay, this distance up to the point C. So 375, 0.375 is the value. Then you consider this 600 Newton force. This is even we are hinging at C and we are applying a force at the point C. It will not have rotation, no distance. And also this 716 Newton force, this is also horizontal force. This line of application meet the hinge point. There is no distance, so it is also moment. It won't create moment. It's 0. So total sum of the moment will be minus 300 Newton meter. Then with this value, how to find the location of the resultant force? Now I am considering. Okay. Now I am considering that in this line of action, the force is acting at this point, this intersection point AB. This intersection point, the resultant is acting. I am assuming that. So then only we can able to find the intersection of the resultant with the edge AB. Okay. So this by the Wagner's theorem says that the sum of the algebraic sum of all moment will be equal to the moment due to the resultant at C. Okay, moment due to the resultant. So this resultant force, okay, this resultant force resolving means sigma h and sigma v. So you convert this inclined force into sigma h and sigma v. Now these sigma h and sigma v will create the moment, right? Will create the moment. Okay, so here also you hinge at the point C. Okay, hinge at the point C. This horizontal force, I am applying sigma h. Okay, when I apply horizontal force, it will rotate in which direction? Clockwise direction. So it is plus. So sigma h value is, we know that this is 560 sigma h, and perpendicular distance. So this horizontal force, perpendicular distance is this distance. Okay, this horizontal force, this perpendicular distance is 0.375. Then sigma v, so upward force, hinge at the point C, sigma v, it will try to move up. Okay, so rotate in anti-clockwise direction. So it is minus the force value. Sigma v is 1200 into distance. Okay, perpendicular distance. This is vertical force, right? So vertical force, the perpendicular distance is this distance, A, unknown value, A. So for solving, we find the value of A as like this. Okay, so now we find the value of A. Then in order to find the value of B, what we can do means, we are assuming that the force is acting at this point. So we can assume at any distance, right? Because the force can be transmitted to at any place in the body in its line of action. So I am assuming that the force is applied at the point of intersection of this CD with this line of intersection, this point. So here I draw sigma h and sigma v. Now find the moment about C, right? Moment about C. Here this sigma h, this horizontal force will not create moment because the horizontal force, this line of application is aligned with the point C, hinge point. So sigma h will not create moment, but sigma v will create moment, upward force, right? Upward force will create the body to rotate in anti-clockwise direction. So minus force value is 1200 into distance, perpendicular distance, this vertical force. Okay, perpendicular distance is this value B. So this B. Okay, so from this we can find the value of B as 0.25. So we located the force and we find the intersection points along AB and CD. We find the value of A and B. Okay.